Welcome to the very last module of the whole course. I'm Emmy and I'll guide you through the binomial theorem. Feel free to pause the presentation at any time. A binomial is a polynomial with two terms, such as 2x plus 3, x squared plus 3, x squared plus 4x, and so on. The binomial theorem tells us what the expanded form is if we multiply the binomials by itself. Suppose we have an addition of two terms, x and y, taken to the power of n. Then the binomial theorem states that the expansion is given by what you see here. X plus y to the power of n is equal to n choose 0 times x to the power of n plus n choose 1 times x to the power of n minus 1 times y, and so on until n choose n times y to the power of n. Alternatively, you can use the NCR notation as you see here. The term n choose r times x to the power of n minus r times y to the power of r is called the general term, and a particular r value in this general term corresponds to a term in the expanded form. The values of r range from 0 to n. The numbers n choose 0, n choose 1, and so on are called the binomial coefficients. The coefficients can also be found using Pascal's triangle, part of which is shown here. The first row corresponds to the coefficients when n equals to 0, and the second row corresponds to the coefficient when n equals to 1, and so on. We start the row with 1, and the second one with 1 and 1. We keep the outer numbers as 1, and the corresponding numbers in each row can be found from the addition of the above two numbers. For example, in the fifth row, you can see the second value by addition of the above two numbers, 1 and 3. You can continue this to get the new rows. Let's have a look at an example. Here we want to expand x plus 2 to the power 7. So if we use the binomial theorem, we replace all n with 7 and y with 2, and we get the expanded form we see here. We can simplify further, and we get the final expanded form. You can calculate the binomial coefficients manually or using Pascal's triangle. Let's have a look at one more example. Here we want to find the coefficient of x to the power 4 when we expand 2x minus 3 to the power 7. We can of course expand this using the binomial theorem, but since we are only interested in one term, we can just use the general term. We want to find the coefficient of x to the power 4, which means we have to identify the r value that results in the general term with x to the power 4 in it. Since the power of x term is 7 minus r in the general term, we need r to be 3. So from this, we can work out that the general term will be minus 15,120 times x to the power 4, and so the coefficient is minus 15,120. Let's have a look at a harder example. Here we want to find the coefficient of x to the power 5 in the expansion of x plus 3 times x plus 2 to the power 6. Here we can expand x plus 2 to the power 6, then multiply it by x plus 3. But since we are interested only with the coefficient of x to the power 5, we can just consider two general terms with the expansion of x plus 2 to the power 6. One general term is a term with x to the power 4, which multiplied by x will result in containing x to the power 5. The other general term is a term with x to the power 5, which multiplied by 3 will result in 3 times the coefficient of that term. So that means we can just add the coefficients of x to the power 4 from the expansion of x plus 2 to the power 6, and 3 times the coefficient of x to the power 5 from the expansion of x plus 2 to the power 6. The corresponding coefficients from the expansion of x plus 2 to the power 6 is 60 and 12. So therefore, the coefficient of x to the power 5 for the whole expansion is 60 plus 12 times 3, which is 96. Here are some practice questions for you to do. Pause this slide to have an attempt at it. Here are the answers.